Set language. Today we are going to see exercise 1.2 in set language. The first question is find the cardinal number of the following sets. First one, M is equal to set of P, Q, R, S, T and U. What is cardinal number? Actually cardinal number is the number of elements present in a set. So if you count the number of elements in this set, what's the answer? 1, 2, 3, 4, 5 and 6. So n of m is equal to 6. So this is the representation for cardinal number, that is n of the set. So n of, here the set is m and we say n of m is equal to 6. Here the next question is p is equal to x such that x is equal to 3n plus 2, and it's mentioned here n is an element of whole numbers and x, that is the elements in p are less than 15. So first we need to find n. So n starts from 0. So what will be the n for the second question? That is 0, 1, 2, 3, 4, 5, 6, 7, 8, etc. It goes on. So it's an element of whole numbers. Okay, it goes on. So there is no restriction for this. So for every n we need to find x. So for 0, x value will be 3 into 0 plus 2. So the answer will be here 2. Again for 1, 3 into 1 plus 2. So 3 plus 2, that is 5. For 2, 3 into 2 plus 2. So 3 into 2 is equal to 6 plus 2 is 8. For 3, 3 into 3 is 9. 9 plus 2, 11. For 4, it will be 3 into 4 is 12. 12 plus 2, 14. So see here it's mentioned x should be less than 15. So the last value will be 14. If you see the next number, it will be greater than 14. For example, we can see one. Take 5. 3 into 5 is 15. 15 plus 2 will be 17. So this 17 will not be included in this set. So the answer will be x is equal to element of 2, 5, 8, 11 and 14. So now we can find n of x, the cardinal number of x. N of x is equal to 1, 2, 3, 4, 5. 5. So the answer is 5 here. So now we can go to the next question, that is question 3. In 3 it's mentioned q is equal to y such that y is equal to 4 by 3n and n is element of natural numbers. So what are the natural numbers? It starts from 1. So we can say n is equal to 1, 2, 3, 4. It goes on like this. Okay. Okay. Here but for n there is a instruction. So we can consider this instruction. What's the instruction here? It starts from it's mentioned that it starts from 2. So it's less n is greater than 2. So it should be 3, not 1 and 2. From 3 we need to start, and it ends in 5 because here it's this sign is equal to sign, less than or equal to. So it should be less than or equal to 5. So we need to include 5 here. So 3, 4 and 5 will be the answer for n. So now we have found n. So for the for these numbers we need to find the corresponding elements. The corresponding y elements will be 4 by 3 into 3, comma 4 by 3 into 4, comma 4 by 3 into 5. So the answer will be 4 by 9, 4 by 12 and 4 by 15. Now we can find the elements of y. These are the elements of y. Now we can find the cardinal number of y. That is n of y is equal to, count here, count the elements 1, 2 and 3. So n of y is equal to 3. This is the answer for, sorry, n of q. N of q is equal to 3. We have found y. The set is q. It's mentioned as q. See the question, q is the set. So q is equal to element of, set of 4 by 9, 4 by 12 and 4 by 15. So n of q is equal to 3. So we have found the answer for 3. Next we can go for the next question, that is question number 4. In 4 it's mentioned R is equal to, R is a set and R is equal to x such that x is an integer. What is an integer? Actually it goes like this: 0, 1, 2, 3 to infinity here, and here minus 1, minus 2, etc. Here also infinity. This is set of integers. Okay. So here there is a restriction for x. It's mentioned that it should be less than, x should be greater than 5, minus 5, and it should be less than or equal to 5. So if you go like this, here minus 4 and here minus 5. Here you should not include this minus 5 because no equal to sign is here. So you just avoid this. So we need to start from minus 4. Minus 4, minus 3, minus 2, minus 1, 0, 1, 2. Again it goes till 5. Here equal to sign is there. So we need to include 5. 2, 3, 4, 5. So what are the elements? 1, 2. So the elements of R, the set R are minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4 and 5. And 5. So what are the, now we can find n of R. What is n of R? N of R is equal to, we need to count the number of elements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Going to see the fifth question. It's mentioned that S is equal to the set of leap years between 1882 and 1906. So from this question we can understand that the years between 1882 and 1906 which are leap years are the elements of this set. So we need to find that whether this is a, first we can find whether this is a leap year. We need to divide by 4. 4 4s are 16. So 28. 4 7s are 28. You have a remainder 2. So this is not a leap year, but if you add 2 here, you will get 1884. So 1884 will be, the next leap year will be 1884. And that is, you need another 2 here. So S will be a set of 1884. Then add 4 here. So 1888, next leap year. Again add 4, you will get 1892. Again 4, 1896. Again 4, 1900. Again if you add 1904. The next leap year will be 1908. We need numbers between 1882 and 1906. So this is the last one. So we can close the set here. So if you find the number of elements, you can find it's 1, 2, 3, 4, 5. We have not included this because this is a century year. This is not a leap year, but this is a century year. Why we say this as century year? Because here zeros are present. Because of these zeros, we say this one is a century year. Any century year divided by 400 is a leap year, not divided by 4. So we need to divide this by 400. But if you divide this number by 400, it's not possible for you to divide. It won't go for 400. So we can say this one is not a leap year. It goes for 4 but not for 400. You cannot divide this number by 400, so this is not a leap year. So we can, the other elements are the set of this. Yes. So S is a set of 1884, 1888, 1892, 1896 and 1904. This one is wrong. We should not include that number which is divided by 4 because it's a century year and it should only be divided by 400 to make it a leap year, to find whether it is a leap year or not. So, for example, we can say 1600. This 1600 is divided by 400. So 1600 is a leap year. But 1900 is not a leap year because you cannot divide 1900 by 400. So this is not possible. So this is not a leap year. N of S here is equal to, N of S is equal to number of elements in S. 1, 2, 3, 4 and 5. N of S is equal to 5. The cardinal number of set S is equal to 5. That's the answer. So that's all for today. Thank you.